Alright, so today we're going to look at simplifying some ratios. Alright, so 4 parts to 10 parts. So it's the simplest way of saying that. So a similar example would be 5 parts to 10 parts. So if someone got 5 parts of a prize versus someone else getting 10 parts of the prize, what's the simplest way of saying that? Well, one person gets double what the other person gets. So you could say that's the same as the ratio 1 to 2. How can I get from here to here? Well, a bit like simplifying fractions. If the same number divides into both sides of the ratio, in this case it's 5, then I can simplify the ratio down. So I need to think of a similar number that divides into, not similar, the exact same number that divides into 4 and 10. So like simplifying fractions, I know they both divide by 2 because they're both even numbers. So 2 and 5. Can I simplify again? Well, I could if it was possible, but no, I can't simplify any. There's no number that divides into both 2 and 5 other than 1 because they're both prime. Okay, so let's look at a second example. A ratio must be given as a whole number. In this second example, we have a decimal. It could be a fraction, but it's a decimal. So this is very awkward to deal with. Now, if I can divide both sides by the same thing, and it doesn't change it, also multiplying by the same thing both sides doesn't change it. We've increased them both by the same amount. So I'm going to multiply both sides by the same amount so they both become whole numbers. So how would I make this a whole number? Well, there's 3 decimal places here. So if I multiply this by 1,000, that would remove the decimal places, removing it 3 places, so I get 35. Now if I multiply that side by 1,000, I must also multiply this side by 1,000. And I get, well, it's going to be 700. So this left-hand side is far bigger than the right-hand side of the ratio. Can I simplify this even further? Yes, of course I can. I can see that they end in a 0 and 5, so that means they're divisible now by 5. So as long as I do the same thing to both sides, it's okay. So if I divide this by 5, I get, well, 5 into 7 goes once, carry the 2, 5 into 20 goes 4 times, and there's the remainder, you can do that on the calculator, 140 and 7. Now if I divide it by once, do I just stop? Well, I notice that I can also divide again by 7. I notice a 14 here and a 7. So if I divide both sides by 7, I would get 1 here and 20 here. And that's the lowest we can go with that. So that's fully simplified. So notice at the start, if we have decimals at the start, we need to make them into whole numbers first. And then we can compare the ratios, and then we can simplify back down bit by bit. What about if we have 2 different units? So it's very hard to compare things that are in 2 different units. So if I just made the jump to saying that's straight 10 to 5 when we compare them, that doesn't make any sense. If I want to compare 10 minutes to 5 hours, I know 5 hours is far bigger than 10 minutes. It's a much longer time duration. So I have to make sure they're in the same unit. So I'm going to convert. Well, which one do I convert to which? Well, if I convert 10 minutes into hours, it's going to be a decimal or a fraction of an hour. So it's easier to convert the hours into minutes. So I'm going to do that. So there's 60 minutes in an hour. So if I multiply that by 60, I get 300 minutes. Now, do I have to multiply this side by 60? No, because it's already in minutes, and I'm only starting off this. So it's 10 to 300 to start off. So once it's in the same unit, then I can start my simplifying process, where I do the same thing to both sides. I can divide this one by 10, and divide this one by 10. So the same thing to both sides. 10 to 10 goes once, 10 to 300 goes 30. So actually 5 hours is 30 times bigger than 10 minutes. And that makes sense. 5 hours is far longer. Lastly, what happens if we're dealing with some awkward fractions? It's very hard to compare these two. They're not technically, well, I suppose, in the same unit, because one's fourths and the other's tenths, and they're mixed numbers. So first of all, let's make them improper fractions. So 2 times 4 gives 8, plus the 3 gives 11 over 4, so we should be able to convert from mixed to improper. 10 times 1 gives 10, so we have 17 over 10. This is not in the same unit again. One's in fourths, one's in tenths. So we need to find a common unit to deal with these in, a common denominator. So let's pick 20, 10 and 4 both divided by 20. So we'll make them both out of 20. I'm going to multiply this by 2 and this by 2. 34 twentieths. And this by 5, this by 5. 55 twentieths. Now, I've multiplied both sides by different numbers. Well, I haven't really multiplied both sides by 1, because 2 over 2 is 1, and 5 over 5 is 1, so that's fine. Just getting them into the same unit, so I've multiplied both sides by 1. So I've multiplied the top and divided the bottom. So I haven't broken any rules yet. Now, if they're both in 20ths, that means they're comparable. So 55 20ths over 30 20ths, it's like saying 55 minutes, 34 minutes. So 20ths doesn't really matter anymore. So I don't need that. I can just say it's 55 parts to 34 parts. Okay, can I simplify further here? Well, I'm thinking. This is divisible by 5 and 11 and 1 and 55. I don't think anything more than that. This doesn't have any common factors, so I don't think I can divide by anything here, and that is its simplest form. So 55 to 34 is a ratio representation, simplified, of 2 3/4 to 1 7/10. So it does make sense that the left-hand side of the ratio will be bigger than the right-hand side, so 55 to 34 parts. So I split up into parts with the same denominator, and then they can be compared. So there's the 4 main different types of simplifying ratios that you can be given.